Testing with her, and she is in room.
Who again?
Miss Flynn, Flinn. Oh, you don't need to go till 8:45, but she is in room 1702
1702, and I am supposed to go there now.
at 8:45.
8:45.
Yeah, so soon.
And what's that about, or?
Something testing, foreign language testing, ESL stuff, I don't know.
What'd you get on that test? Did I tell you that I got 8 out of 25 on it?
I think I forgot it, bro. I'm not gonna lie. Now that I'm thinking about it, yeah.
I don't even know what number it was, because there could be more than one word.
It's either in my car, and I'm pretty sure it's in my car, but it also could be in my room. My bad. like actually die if that man comes in with like 100 people's IDs. Teacher can't do anything. Like if he doesn't handle it, teacher can't take it. He said he's just gonna. I don't know what wants him though. Like, it's kind of weird. It's funny. Like, imagine he pulls out just like a million IDs.
You know what was the last story that
I've got an ID from everyone in the school.
me? Of course. You're like the only you're like the only people in the hall. You're like, you're like oxygen.
Somebody asked me if it's giving mine for $2. I refuse to pay $2.
Yeah, what's he was paying people $1.
Why are you wasting money?
You know, it's so that you can get another one because it costs money to get another one.
If you're paying $2 to get someone else's, you're wasting money.
Imagine he just spends like $200 on IDs. For rec one it's $4K and then for a non-rec one it's like
I want to pump that truck so bad. I love that stuff. How are we doing today, Jimmy?
It's Friday, so not too bad.
Great day.
Yeah.
No, I really my eyes. I
I do not like math.
Honestly, it's not easy.
It's pretty easy so far,
It's
yeah.
gonna get hard.
Probably, but it's been pretty easy so far. But I just have a hard feeling that we're about to take a sharp right turn, and I'm about to.
Whenever we take that sharp right turn, still going straight or something.
Uncooked.
What do you think about psychology? I'm not. No, it's like weird.
Yeah.
All the like, what are they called? Like ways to. What are they called? Stuff we've been studying.
Approaches?
Yeah, approaches. They just all seem the same to me. I can't tell the difference.
It's alright.
And I haven't even started on that module.
So what's the?
Like the stuff that you have to fill out from the book. The packet.
Oh yeah. You know she was going over a lot of that during class, right?
Yeah, well I got those filled out. But there's like 3 more pages. No one else did.
Oh, the day of the test, the next Friday.
Is that why you were late?
Or no.
It's not gonna be that late every time because you were late last time.
No, it will be next Friday because that's Labor Day. Yeah.
Sounds good. Yeah.
All right, you guys will need a blank piece of paper today, so please get that out. Okay, so after our quiz on Wednesday, we took some notes over section 4.3, and I tried to point out to you how it was kind of split into 2 halves. The front half of those notes were SOHCAHTOA, finding ratios, finding side lengths of triangles, finding angles of triangles. Probably not a terrible idea to have number 12 out, those notes, in case you want to look at those. So for the first half of this unit, we're going to practice those question types, which would be the SOHCAHTOA question types. And so we need to try to get as much practice in as we can today through this book assignment. So on your blank piece of paper, go ahead and start copying the assignment down. And we'll look at a couple together here in just a moment to help you get started. You got it sorted out yet?
Yeah.
Okay, I've got you in 12, which is the very furthest one for this class. Nissan. 2, 3. Kramer. Aiden. Oh yeah, we've got a lot of school business today. 3. Read. Okay, so we need to try to get two things behind us today. We need to get in some SOHCAHTOA practice so that if you don't remember that very well from geometry, you at least feel like you're not behind everybody else. So that's what this book assignment hopes to achieve. And then the second thing, as you get to it, which might, well, some of it will be homework, I guess, but the back page of the notes we did last time, number 12, you need to make sure you have those memorized before next class. I'm sure you guys have not forgotten, but there is no school on Monday. Tuesday will be a B day because Tuesdays are always B days. So I won't see you again until next Wednesday. Let's go ahead and look at a couple together. And I don't know, the first few assignments we've done out of the book, I helped you out with the vocab check. This time I'm going to let you guys try the vocab check on your own before you tell me which ones you may need help with. That being said, it's probably a good idea to at least leave some space there. I don't want you to get half credit on your assignment because you forget the vocab check, but that does happen sometimes. So let's look at one of these just as a kind of a quick little reteach. So question 5 wants us to find the exact values of the 6 trig functions. And they give us this to work with. So this is like the bottom example we did on the front page of our notes last time. If it wants all 6 trig functions, that's going to be sine, cosine, tangent, and of course their reciprocals. But other than a few unit circle type questions, again, all of this is trying to make sure that you can do everything you can or need to with SOHCAHTOA. So the first common mistake is mislabeling the opposite, the adjacent, and the hypotenuse. Typically you guys do a good job of knowing which one's the hypotenuse. It's the biggest side, the side opposite the right angle. But sometimes there'll be students that get mixed up the opposite and the adjacent. So you need to remember for opposite and adjacent, that is relative. Opposite means directly across from the angle you're looking at. So if I'm looking at this angle, 6 is opposite. But if I was looking at this angle for some other reason, 8 would be opposite. And then the side that's next to the angle that's not already the hypotenuse is adjacent. So it looks like I have opposite and adjacent, so my tangent answer should come pretty easily. Go ahead and reduce your fraction. And then we can see that sine and cosine both need the hypotenuse. So to find the third side, as long as it's a right triangle, we can do Pythagorean theorem. Make sure your hypotenuse is C. Which leg you call A and which leg you call B doesn't matter. It looks like the hypotenuse would have been 10. You will not have to memorize any Pythagorean triples in this class, but do you guys know about the 3, 4, 5 triangle? Okay, so if you really know that one, this was the same thing. This is a 6, 8, 10. It's proportional. So if this is double 3 and this is double 4, then this was going to be double 5. So sometimes you can actually skip the Pythagorean theorem if it's a Pythagorean triple, if you cared to memorize those. So now that I've got that, I could pair up adjacent over hypotenuse to get cosine. Again, you should reduce your fraction. I've got opposite over hypotenuse, which would be sine. And if you can do sine, cosine, tangent, then you can certainly do secant, or cosecant, secant, and cotangent, because those are just reciprocals. Okay, so just kind of our quick little refresh there. Any questions about 5? Any of that parts I'm doing that you didn't quite catch? Okay, let me give you a couple minutes to try questions 7 and 11. So I'll give you about 5 minutes to do those two. And if you need me to go over one or both of those later, we can. But for right now, I'm giving you 5 minutes to start them. And then we'll jump ahead and look at the next question type. So I'm going to do a little bit of each question type with you guys and try to give you some space in between for you to practice a little bit. And then at the end of class, I'll give you time to finish. Okay, there was 5 minutes, so if you didn't finish the next two questions, what was that, 7 and 11? Was those the two you were doing? Okay, then maybe make a little bit of space and you can come back and finish those up, and if you have questions then you'll be able to ask here after we look at a little bit of all of this. So, okay, so that we're all on the same page though. Kind of pause where you're at and jump ahead to question 15. This is 95% the same thing, but it starts off a little bit different. So the first one I did for you gave you a triangle. The triangle was already drawn for you. And then question 15 still wants us to find the exact value. So that means no rounding, no putting it in the calculator and getting a decimal. Bless you. Exact values only. The other 5 trig functions, because really if they tell us cosine, then we know one of them. So we need to be able to get his reciprocal, but also figure out sine and his reciprocal and tangent and his reciprocal. Now the key to this, to make it just like question 5, is if you understood what to do on 5, 7, and 11, because the triangle was drawn for you, make a triangle out of this. Sketch a triangle, pick one of the angles to be theta, and if cosine's given to you, label your adjacent side as 15, and then what side should I label as 17? Hypotenuse. Cosine is always adjacent over hypotenuse. That's the word SOHCAHTOA and how it's supposed to help us out here. Now, that really doesn't mean this length is 15 and this length is 17. It's proportional. This length could be 30 and this length could be 34. Yeah. But proportion-wise, for every 15 in length here, there's 17 in length here. So, I feel like this might be a Pythagorean triple, and I'll probably know in a couple weeks when I'm more familiar using these again. But for right now, I don't recognize the Pythagorean triple, so I can do Pythagorean theorem. This is where you might have wanted a calculator. Okay, we get a squared is 64. So a could be plus or minus 8, but the way we're using it, we just want the positive length. So you can see how it's basically the same question as number 5 now. So I tried to do that in red. They gave us the cosine ratio, so make a triangle out of that. Again, take this information that was given to us and make the triangle, label adjacent and hypotenuse, because sine was the information they gave to us. If you need the third side, you don't always need it, but if you do, Pythagorean theorem, then finish the other 4 with SOHCAHTOA. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite, tangent is opposite over adjacent, so cotangent is adjacent over opposite. Okay, anything that jumps out at you about 15 you want to ask? You're okay with how I set that up? Started it? Okay, there's only one more like this on here, and it is number 17. So I'm gonna give you, let's say, 4 minutes to try 17, see how you do. If 4 minutes is too long, you can go back and finish up number 7 or 11 while you wait. Since you'll need to go back and finish those later anyway. I am going to take off question 68 from your assignment, so you might want to cross that one off. You don't have to do that one. It's kind of a longer question, and in January when we do law of sines, law of cosines, we can show you a more efficient way to do it, so it's kind of silly to spend 10 minutes of class talking about it. So if you want a good challenge, try 68. But you don't have to have it for your homework grade. Okay, we're going to move on in about 30 seconds, so try to find a stop in place. Alright, looks like the next one in our assignment is 23. And so for this section of questions, 23 through 28, this is actually not unique to this section. In fact, at the very top of our notes last class, it says if you're still uncomfortable with the unit circle, you need to continue practicing that. And that's what these questions 23 through 28 are. They have nothing to do with SOHCAHTOA, everything to do with unit circle. So, question 23 says that our function is tangent, and the angle they want us to look at is 30 degrees. We're supposed to figure out what that angle is in radians, and then what the function value is. And all function value means is what is the tangent of 30 degrees equal to. So if we think about the unit circle, here's where 30 degrees lands. How many radians is it there? 5 or 6. So if you have the unit circle memorized, that's quick. If you don't have the unit circle memorized, that's going to cause you other issues. But remember, I guess if you just brain freeze or something, you could multiply by this and you could figure it out with that tool that we showed you in 4.1. So second option. Now for the tangent of 30 degrees, to find tangent values, we're going to have to know the unit circle point, big X, small y. Big value was square root of 3 over 2, small value was 1/2. That's how I remember that. This one is sine. This one is cosine. So the quotient identity says take sine divided by cosine. And dividing fractions is the same thing as multiplying by reciprocals. Notice the 2's are going to cancel. Whether you reduce here or in the next step, you need to do that. And then finally, you're still on the hook for rationalizing. Rationalizing is not too big of a thing in calculus, but in trig it's very big. You check your answer in the back of the book, there's no chance it's going to look like this. They're going to multiply the top and the bottom by the square root of 3 to rationalize the denominator. So these are the two answers I wanted. Basically, how many radians is 30 degrees, and then what is the tangent of 30, or what's the tangent of pi over 6? So again, just unit circle. I say just, I know that's still part of your learning process, but if you're serious about taking calculus next year, you can't spend 4 minutes to think about a unit circle question. You're never going to get finished with the calculus if you're that slow. So we have all semester to improve on that, but you got to get a little bit better. Okay, so 24 through 28 are also unit circle type questions. But I know this function value, again, make sure you update your notes here, just basically means what is it equal to? What's the tangent of 30 degrees equal to? Go to the unit circle and try to figure that out. So let's say there's 1, 2, 3, 4, 5 more of those. So, I don't know, let's say 5 minutes. 5 minutes to get at least a couple of them done. Again, I realize I'm not giving you enough time to do all of those, but there'll be time after. I'm just trying to give you some time to put pencil to paper, help it sink in, and once we look at a couple of each type together on the board, I can come around the room and help you with whichever type is giving you the most trouble. Okay, go ahead and find the stopping place. And we'll jump ahead to 38. Okay, so for 38 and I think 2 more questions after that, it kind of looks like a multiple choice question, but it's not. It's just wanting us to work out 4 different things. And it's also a little confusing because you should be able to give me all 4 of these answers based on what we know about the unit circle. 30 degrees and 60 degrees lands on the unit circle. We have those points memorized, so we have sine and cosine. If you have sine and cosine, you can divide them to get tangent, and you can flip them to get secant, cosecant, or cotangent. But they're trying to make this just a tad bit easier, I'm guessing since unit circle is still a little new to you, by giving you 2 hints up here. So even though I could work out A without these hints, it's a little bit quicker to just say, well, cosecant and sine are reciprocals, so if you're talking about the same angle, 1/2 becomes 2. What's another one of these that you could do pretty quickly using one of these hints? B as in boy. I think I could do that one quickly, but I'd be surprised if y'all could. What about this one? Shouldn't this just be the reciprocal of that one? Same angle, reciprocal functions. So don't write it as this. Again, you need to rationalize. You have to multiply the top and the bottom by the square root of 3, and then your fraction reduces. Okay, I don't know that either one of these really helps with part C, but cosine at 30 degrees is probably just as quick just to think of the unit circle. At 30 degrees, it's the big X length, so square root of 3 over 2. And there's 2 ways you could do B. So the way I would expect you to do it, I'll show you a little bit of a shortcut if you're willing to learn one of those basic identities though, is cotangent at 60. Well, I can always go to 60. Think about the point from the unit circle. Tangent is sine divided by cosine, so cotangent would be cosine divided by sine. And then after we rationalize, you could end up with that. So that's the long way, I guess. Think about what you know about 60, think about sine and cosine, think about how sine and cosine gets you cotangent. But there is a much quicker way, but again, this is kind of a stretch early in the year, but I still like to show it to you because if you know it, then you can save a lot of time. On the back page of your notes, there is one thing called cofunctions that don't have a ton of use right now. But one of them says if you want to know the cotangent of an angle, like this one, it's the same as the tangent of the complementary angle. So if I want to know the cotangent of 60 degrees, that cofunction tells me it's the same as the tangent of 30 degrees. So the answer was really just right there. But until you memorize this cofunction and understand what it's saying, these 2 are cofunctions. So the cotangent of an angle is always the same as the tangent of its complement. Likewise, the tangent of an angle is the same as the cotangent of its complement. complementary angle. You can't take that shortcut, but just an option. Okay, so there's all parts of 38. It looks like, is there anything you guys want to ask about 38 before I ask you to try the next couple that are like that? Okay, to me 39 and 40 look like the same question type, so let me give you, I don't know, 4 minutes. Just try those first. If you finish those and still have time left over, you can go back to one you didn't have time to finish yet. But try those first. Try to find a stopping place there. And we got 2 more types we need to look at together. So 53 will be the first of those. Okay, and part of what I would say, I'd put a star by this. When our quiz in section 4.3 is a few classes away, we spend more time in this section because there's more we need to get out of it. But this question type is probably the most missed type on our 4.3 quiz. And it's not that it's really any harder than the other questions or really even that much different, but if you're not familiar with what the directions are asking or what to do, then you do get stumped pretty easily. So the directions say find the value of theta in degrees and radians where theta is between 0 and 90 degrees and 0 and pi over 2 radians. So that's a real long-winded way to say in quadrant 1. So basically, where is sine 1/2 in quadrant 1? So still unit circle, but it's kind of backwards because usually in unit circle you're told the spot to go to. You have to think of the point, and then the point gives you the trig value. This instead is saying what angle is going to have a sine of 1/2. So since sine is the y values on the unit circle, which one of these points has a sine of 1/2? I'm sorry? 30 degrees has a sine of 1/2. And how many radians is that? 5 or 6. So still unit circle knowledge, but working the question backwards. Okay, part B has 2 parts to it. So directions still stay in quadrant 1. And that's kind of important because, by the way, sine is 1/2 2 places. It's not just 1/2 at pi over 6, but it's also 1/2 at 5 pi over 6. That'll be something we have to worry about later on when we do inverse functions, but for now. Now this one, you don't memorize, when you memorize the unit circle, you memorize sine and cosine values. You don't memorize cosecant values. So for a question like this, you need to take one step and change it. If you know cosecant is 2, you should know that sine is what? 1/2. So do you see how these are really the same thing now? But you have to know to try to switch it to make it look more familiar. So the answer to this part is also 30 degrees and pi over 6 radians. I think 1 or 2 of these may be a little bit harder, but I think it's good for you to try it. So let's see, that was 53. You're also supposed to do 55 and 57. Oh, those aren't too bad. Okay, so there's really like 4 questions there, so let me give you like, let's say 5 minutes. 5 minutes to try to do the next 2. Sign out, take it.
2/2. You know, it's over the square root of 2/2, which is 1. Because it's thinking of I don't know.
So they don't have the same answer.
No.
I got 45 on that. This one's
You were supposed to do 40. You were supposed to do 54.
we were supposed to do 55.
Yeah.
That's what it is.
Okay, so it's been about 5 minutes.
But
So
yeah, you were right. Yeah.
take a moment here to write down your thought, and let's look at one more question together on the board, and then I can let you work more at your own pace here and kind of reset, go back to the beginning. Okay, so 59 gives us a right triangle and one length of 18. Sorry, my picture is pretty bad here. Try again. Okay, and from this, we should be able to solve for the length of x and solve for the length of y. So, I think this is the first time in the assignment we need to use SOHCAHTOA to find angles and or sides. This one just happens to be sides. So, you got to look from one of your acute angles, like 60 degrees. I guess you could solve that this one's 30 and look from that, but that would be more work, so I don't know why you would. I just kind of picked the one given to me. And now I'm not going to use tangent. This is SOHCAHTOA. The problem with picking out tangent is you would put opposite, which I don't know, over adjacent that I don't know. And I can't solve an equation that I have two unknowns to. So instead of tangent, maybe I could pick like sine. Sine lets me pair up opposite over hypotenuse. And now this equation only has one unknown, so we can solve it by multiplying both sides by 18. So it looks like the y length is 18 times the sine of 60. I guess you could put that in your calculator, but honestly, this is one that, if this is a unit circle spot, we really should be practicing this without a calculator. At 60 degrees, sine is the y value, which is square root of 3 over 2. So if we reduce that, that length is exactly, not even a decimal, even better, exact answer is 9 square root of 3. So if y'all didn't believe me in section 4.2 how big unit circle was going to be, you should probably start to believe me now. Shows up in everything basically. Of course, this was supposed to be, sorry, that's for y. Okay, and then for x, I guess technically I could use tangent now because I know this length, but I kind of want to avoid square roots in my work. That might be kind of messy. So instead, I'm going to pick from 60 degrees, maybe do cosine. And the reason why I'm thinking cosine is because cosine lets me pair up the adjacent length, which I'm trying to find, over the hypotenuse length, which I know. This creates an equation that has only one unknown. You solve it by undoing divide by 18 with multiply by 18. And the direction said exact value, so I should try to use the unit circle here. The x value, the cosine value at 60 degrees is 1/2. So x is exactly 9. Also, you might notice that these lengths, 9, 9 square root of 3, and 18, this is just a 30, 60, 90 triangle. So if you really know that ratio, again, you don't need to know this ratio for class, but 30, 60, 90 triangle, for every 1 in the smallest length, there's 1 square root of 3 in the middle length and 2 in the biggest length. It's proportional. Multiply by 9, multiply by 9, multiply by 9. So I guess you could even take that shortcut on that one. But you need to see how I use SOHCAHTOA to set up equations so that I could solve those equations and get those links. Okay, I think there's several that ask you to do this. The next one is 64. That one you would need to draw a picture for. Actually, you might skip 64 for right now. We can talk about that one later. Maybe 65 too. 66 looks very similar. 66 just wants you to find the side of a right triangle. So maybe save some space for the other two and then try 66. So other than a couple oddball questions here, we looked at least one of a few different types. So I don't know, if I was you, I'd maybe finish up the question you're on and then kind of reset. So go try the vocab check, see if you can answer those. I know you already tried number 7, but if you didn't finish it or you got stuck on it, you can call me over to help. If you didn't have time to finish number 11, you can do that and just start filling in the ones that I didn't give you enough time for. Start on that. And keep your phone up for a minute. Don't let me take it. Okay, and then as I come around, again, I know you have tried a few of each of these, hopefully. So if you know that you're struggling with one, just let me know. this one, what I would say is compare this to like what we did here. Remember how I took this information and made a triangle out of it? So take this information, make a triangle out of it, and then go to the other side, and then you should be able to get those two. And then this one, you'll want to look at your notes. This is a cofunction, so this is equal to something else, and that answer is sitting over here somewhere. So look at your notes to see what that's equal to. Okay, this is the last pencil I'm giving you. I don't have budget for pencils. Nobody else has any questions yet? Are you trying to find an angle though? So inverse sine, that makes sense. So put sine on the outside, and then inverse, there you go. So that's what you want to throw in your calculator. And does it say how to round? In yours? Something? Because what's happening here is you're basically asking your calculator what's an angle that has a sine, whereas opposite is this and its hypotenuse is that. And hypotenuse has to be the biggest side, right? Yeah. So it gets confused. Yeah. Yeah, but make sure you write on your thing here how you got that, so you remember when you look back at it. Sine is 54 and then just became 54. Okay, so W is here in green mode, and then we'll do I didn't take the rest of it, let's see, so that's 54, and it's in there. Three decimal places, that should match up. Don't forget to occasionally check your odd answers. Preferably every once in a while, so you don't have to go back and redo them.
I have a question on voting. I'm doing what is
Yeah, to be able to do that one, it'll be after you memorize this. Because this is trying to say that. So you have to know all that mess is the same thing as can.
Okay.
So if you got part A, did you do part A yet? Oh,
So just be
by opposite, do you mean negative? Yes. Yeah, so if you can do B, you can just flip it. So until you memorize it, yeah, that's kind of hard to know.
Something wrong because for Jason I got 1600 and so all these functions are absolutely huge.
Yeah, so your hypotenuse has to be the biggest side.
Yeah, that's what I
My
thought.
guess would be that you didn't do square root there when you did Pythagorean theorem.
Oh, I haven't done Pythagorean theorem since like in a long time, so I probably did it wrong.
names did you have?
I did b squared as 9, so 9 squared equals 41 squared.
I just flipped through the page on accident.
Say that again.
And then the opposite was 9, I did 9 squared.
Okay.
So a squared equals 9 squared equals 41 squared.
So you're calling this 9. What's the other leg? I mean, one's the hypotenuse.
Yeah.
Hypotenuse has to go in for C, and you don't know the other leg.
I don't know.
Okay, so this is 81. This I don't know.
It's 1637.
You can subtract 81 from both sides. That doesn't look right, but
Check that arithmetic.
Let me see.
I think my arithmetic's off.
It's 1681, so it's 6. So
Oh,
equals
this is
16.
16.
Yeah.
So this is, that makes more sense. 1600. Okay, that's not how big that leg is, that's how big that leg squared is. So you still need to square root both sides. And then this
You
would be
get
like 40 or something.
It's 40. Okay.
Now the hypotenuse is the bigger side, so that's the reason.
Yeah.
Yeah, that's what I was saying. I think you just didn't do the square root at the end.
That's what I didn't do.
You guys got one I can help with?
Why is this a decimal though?
Yeah, you need to leave it as a square root though. So you got a squared plus b squared equals c squared. C squared would be 64, right? 8 squared is 64. That's a 3. So that would be 9 then. So the other side is 9. This leg squared is 1. You can subtract it over. Which means this leg squared is 8. So it's the same thing as the square root of 8. So you need to call this square root of 8 instead of that decimal. But the square root of 8 also breaks down. This is probably why that's the same thing. But 8 is 2 times 2 times 2. So the square root of 8 is 2 square roots of 2. Right? It's like the same thing as the square root of 4 times the square root of 2. You get the square root of 8. So see if that fixes what you got. Were you 5th period? Or, no. You were 4th period.
somebody? Okay. If you feel like you know what's going on here, then that might be fine. Otherwise, I would suggest you watch the class report. You never find that. Okay. So if you watch the class report, it's the same speed that they did. So. Yeah, that's not how you solve this. When your variables in your denominator like this, multiply both sides by the variable, so that you don't have fractions anymore, and then divide both sides by the tangent value. So I think you get your fraction for it through. This is why we had to do two examples, because if the variables in the numerator solve one way, but the variables in the denominator take a different process to solve. It just depends. If it was no calculator, that's your exact answer, and that's the best you can do. If we gave you a calculator, then plug it in. I'm gonna guess the back of the book probably rounds when you check your answer. We're gonna get to the point where you're just gonna have to give it to me and start class. I assume that's not what you prefer. Okay, but you're on your phone sometimes when you're not supposed to be, so I can't tell the difference. We got about 17 minutes, so y'all can still get a bit more done here. But our last few minutes, I'll tell you where you need to be by next class. So they want you to think of this in two different ways. So back in geometry, when you have smaller triangles and a bigger triangle like this, these sides are important. Like you could do like 3 to 6. It's the same thing. Small, big, and small, big. So that's one way you could solve that from past geometry proportions across multiplying and solving. The second part of the question that you were asking though is how can we do the same thing with trig? Well, we can find this angle, this little right triangle. That's the inverse.
Increase.
Once you know how big this angle is, you can say, I'm trying to find the opposite side, I know is adjacent side.
Memorize it downward. I wouldn't say it's negative and opposite, but it's angle of.
So you have to do inverse tangent to find the angle, and then you know how big the angle is, you can solve that. But you should get the same answer both ways. You're just trying to show you a different path.
Hello? Hey. Okay, that sounds good. Oh, I don't know why it's not on there. Oh, okay. Mm-hmm. Mm-hmm. Yeah. You're down in your room right now? Okay. Okay, I'll let her know. Bye.
Well, so this is really discussing what's the secant by the board. So since secant is the reciprocal of cosine, just flip over the x value and then you can rationalize it.
Is the wires up there?
You need to go to your collective testing. She's got a room to record sitting on the yourself. So on this, this doesn't have to be finished. This slide, but will memorize these and then it's matching, and then it's still blank, obviously it's not something that is matching. So you need to make sure you have this memorized next time, but the time doesn't have to be that way. Be attention. Wait a minute. It'll take me. She's right down the hall there. Like a piece of a shot. You can take this. It's not a marker. Language testing or something. Yes, but also other students too. I don't know. She'd have to tell you. All I know is what to send you. 68 is when I said you don't have to worry about it, unless you just want to give it a shot. Because there's a lot. Really, let me give you the 10-second answer. So you set up the SOHCAHTOA equation with the big right triangle, and then a separate SOHCAHTOA equation with the small right triangle. You get two equations with two unknowns, and then you can solve those with substitution. Substitution, you've done that before. It's like x plus y is 3, but then 5x minus y is 10. You solve one of them for one variable, substituted in for the other one. You've done that before, right? Yeah. But yeah, don't worry about that because we can do that more efficiently. What's the other one? This one you need to try to make a picture for, and I tried to start over here. The person walking away from the building, so it makes like a smaller right triangle. So just be ready to ask next time. But try it and see where you go. That's 40. That? Yeah. Wire. The guide wire is, I don't know why it's called that, but it's the hypotenuse. Okay. That's the type of thing on a quiz, if you didn't know what it looked like, I'll tell you that. Okay, we've got about 5 minutes here, so I want you to finish your thought and to be very clear about where you need to be next class, because I don't want you to be caught off guard. This book assignment does not have to be finished yet. So unless you feel like you're really struggling and this is harder for you than it is for other people, you do not have to do any more of the book assignment for me between now and next class. But part of that is because I need you to memorize these basic identities, which make up the second half of this section. So on our notes last class, the back page says these must be memorized. So we have our memorization quiz next class, and so it'll ask a couple of these, and they'll be matching. A couple of the reciprocal functions, which are matching. You need to be able to state both quotient identities, that's fill in the blank. You need to be able to state the three Pythagorean identities, those are fill in the blank.
The co-functions are matching. Even, odd is fill in the blank. So the reason you don't need to do the book assignment for homework is because I need you to memorize this back page. The quiz will have no variation. It's a straight up memorization. Even if you don't understand any of it, if you put in the effort, you should get 100 on that quiz. We'll have more class time for book assignment later.
How do you do 39 and 40? Like, I don't understand how you feel.
Yeah, so you could do a little bit of it, but then when I compare this, like if cosine's a third, it's kind of like over here. I knew cosine was something, so I use that information to make a picture, and then Pythagorean theorem to find the third side, and then I can basically get it. So you just need to sketch a triangle for those.
Okay, thank you.
Okay, do I need to repeat that again? Everybody heard what the quiz is next class? Quiz does not have questions like the book assignment, not yet, just the stuff you need to memorize. You don't need one for your other classes?
Rest of the